Hello, today we are here with Nicolas Carlo to interview him, and you're probably already familiar with his work, but in case you're new to this work, I would suggest you take a look to his blog, Understand Legacy Code. You may also want to pick a copy of his book, Legacy Code First Aid Kit, and you should also be familiar with MendorCon, a conference that Nicola is helping organizing. And among other things, he has been also an organizer of the Legacy of Socrates and several meetups. He's originally from France and now living in Montreal. So welcome, Nicola. It's nice to have you here.
Thank you for having me, Federico. It's a pleasure.
Very nice. So let's take advantage of our guest and start asking questions. And I would like to start discussing a definition that you shared that define legacy code as valuable code that you're afraid to change. And I think it's a very relevant definition. So I would like to ask you, why do you think this happened? Why is this the case? And how can we help people being less afraid of doing the changes that they should?
Yes, that's starting from the definition is important because for most developers, when they hear legacy code, they think about painful, bad code, like everything is mixed up. They don't really have a clear definition. Some developers get into the topic and they're like, I want to learn more. And so they probably come across Michael Cleather's very good also definition, which is legacy code is code without test. And most of the time it's accurate and good enough, and you can just use that. Um, Personally, when I was so reading and learning and going through deep in that topic, I needed something more um, complete than this one because I have seen code bases with tests, but the tests were very hard to read, understand, and maintain. They were testing the implementation details. So I was like, okay, there is more to it than just the test. And I don't exactly remember because I know that I didn't come up with this definition myself, like out of my brain. I just read about this. I've probably picked up someone say it maybe in a different way, and then it really resonated with me. And I had also discussions with GB Rainsberger about legacy code, and he also had this kind of definition, and I really liked it. What I like about this definition, so valuable code you're afraid to change, first of all, it accurately represents my experience. It also overlaps with code without test, but it highlights two things: the valuable code part. um, I have worked with startups, and I have seen code that we wrote and 6 months later we threw away completely, or even some of the startups I worked with in my career failed, like we couldn't raise, so the company closed. So there is no legacy here to maintain. So I was like, okay, big part of it, of that legacy code, is the fact that people are using it on prod, and you cannot just rewrite the whole thing. Generally not a good idea, because there is a lot of value. If that's your company code base, it pays your salary also. It's what makes the company successful. And so, on the other hand, any successful company will have their fair share of legacy code. Um, but there is the aspect of you're afraid to change it, which is more subjective. And you can see that in companies where there have been some people here for like a decade or two, and they're like less afraid to change it. So they don't think there is so much of a problem, compared to you just onboarding on that system. And you're like, there are a lot of issues. So it is subjective, and the what I like about it, and to answer your question, how can we help people? Since it is subjective, there are things that people can do and learn to make them more comfortable in tackling these code bases. So, for example, if someone is very fluent in refactorings, automated refactorings, they have read Martin Fuller's book, they know how to do them, they will be less impressed by a very messy code base because they know they can move around compared to someone who is like, I'm afraid I'm gonna break something if I start touching it. So that that's the definition I use most of the time because of this.
Good, thank you. And well, let's continue with definition in a way, because I remember currently your blog mission is to help developer change messy software without breaking it. And so maybe it's similar to what we discussed, but and you mentioned the point that it's very subjective. You know, why should someone be afraid? And some people are braver than others or have more tools at their disposal, like if they're familiar with refactorings. But maybe for the people that are not as familiar with refactoring or not as brave, if you uh, were to share some advice with someone, let's say maybe it's early in their career, maybe a little bit cautious, uh, could you share some advice that comes to mind?
So when you're starting, yes, because that's the thing with legacy, because there are so many things going on that you need to start somewhere. Um, if you're arriving on an existing code base, well, at least that's my experience, one of the first thing I do is to check for what does it take to make a change that goes to production? Because usually there may be some things that are not automated, not documented. Some people who has a special script somewhere on their computer, things like that. That it's usually where I start. It's like let's streamline the onboarding phase, especially since you're arriving on the code base. For you, it's all new, and it's I think the best moment to also identify that there are gaps and improve the docs and automation and all that. That's one thing anyone could do. They could help doing. Even if you're a junior, you can ask questions, and when you get the answers, you put them in the README, for example, and just doing that is it brings a culture of we're gonna make things a little bit better for the next person. So that's the very first thing you can do. The second thing you should look at is probably, well, you want to make changes to the code, but you don't want to do regressions, so you want to lean on tests. Usually they are lacking, and so that's where microfeeders come in with like working effectively with legacy code is first, how can you write automated tests on the current behavior? And so everything around what microfeeders call characterization testing. I found approval testing, which is a similar approach, but it will give you more resources if you look for approval testing for the keywords online. So you have some tools, libraries, techniques to help you capture the current behavior of the system and put some automated tests. So when you start working with it, if you introduce a regression, you know it. And as a developer, these two things will probably be the things to start looking into. In my experience, most people don't know these techniques, but they can really be handy. That's the technical aspect of it. There is one other aspect that is actually very important, so I want to mention it. It is the cultural aspect of it. Like I'm dropping my experience here, but the most difficult part of all of this is the human aspect. It's like how people are doing things today. Are they in? Do they want to improve things? Do they realize there is a problem? All of this is actually harder. Um, but even if you're a junior, you can contribute to by asking questions, by suggesting things, leading by example. Sometimes, like you just show them open doors. Like you're like, oh, have you heard about approval testing? Have you heard about this? Have you heard about that? And this can help move the culture because if you don't change the legacy culture, you won't be able to change the legacy code base anyway.
I think that is very true because in our experience, sometimes people ask us to migrate a code base to another language. Typical scenario, there are maybe a few million lines of code and zero test. And I think one can see some effects of the culture because you can see that a lot of this code is duplicated code and someone maybe took a giant piece of code, copy it and change a tiny bit because perceive that as less
Mhm.
risky. So, like I don't want any responsibility if this crash. So I will do what minimize the effects of causing a problem. And if it doesn't make the code base better, yeah, so be it. So yeah, if we could change culture, we could change that. Uh, but among the advice that we could give someone that needs to deal with legacy code, well, one advice that I could give is to get your book, Legacy Code First Aid Kit. So, and about this book, can you tell us more about who is it intended for? How did you come up with the idea of writing it? Or also, how was the reception? If you received some comments from readers?
Yes. So how did I come to write a book, which I kept it as an ebook, self-published, stuff like that. It was a process because what I've been doing is I've been digging into the topic of legacy code myself. I was a consultant in Paris, and I was also surrounded by software crafters. I was going to the meetup, and software crafters are interested in code quality, code maintainability. So there is, of course, a bunch about writing new code, but there is a lot about how do you improve existing code. So I learned a lot, and I was also, as a consultant, I was also teaching a lot. And then eventually, after some years, I was like, I'm gonna write that in a blog because I also want to like uh, regroup at a single place everything that I'm exploring and finding, and some things are more useful than others. So after some time, after I think 2 years, I was like, okay, I have a lot of different topics and articles, and I wanted to do a shorter, not a shorter because it's actually not that short, but a condensed version of, okay, what are the 14 techniques that I do actually use personally. And so I wanted these techniques to be also detailed with the same approach. So it's like a more deep dive into each of them with like what is the technique, when to use it, how do you do that, why it works. And I wanted also it to be very practical. That's where the first ed kit came out. It was like, okay, I want something for developers who are on the code base in the trenches, and teach them things that they could use. So approval testing. We talk a lot about some refactoring moves. Refactoring is an interesting topic because there are so many refactorings out there that you can learn. But the mindset of refactoring and the few refactorings that you always need most of the time when you're tackling legacy code, I put these into the book. So that's how I came up with this. And I got good feedbacks. Like people were, in general, people are happy with it because it's a place to start, and it's the feedback I got is that it's very pragmatic, like okay, detailing the techniques and with code and everything. And I had the question, I think it was last year, like, is it still up to date? Because that's always the question, like, can you still apply these? Would you still apply these today? And the answer was, yeah, they're pretty much still accurate. That's the great part of legacy code. It's always legacy. You're still struggling with the same issues anyway. Um, it's interesting we could talk about AI and how that impacts it, but most of the book is still very relevant today. And AI could help you at some places, but still the spirit of it is still very relevant.
Good. And now I would like to ask you about one specific technique that I found interesting. And this is the hotspot analysis technique, if I remember the name
Mm.
correctly, that caught my attention. So could you maybe explain for our listener what it is and why it has a good ROI, if you want, why it's has a
Mm.
good return?
Yes, yes, yes. So hotspot analysis, it's one of the techniques of an approach that is called behavioral analysis. And the one person really digging into that topic today is Adam Thornhill. He has been working with that for well, I would say at least a decade. But I've read his books, Software Design X-Rays, and the one that is the most popular is Your Code as a Crime Scene, where he showed hotspot analysis among other things. But the core idea is you have a lot of information that is inside the Git logs or like version control metadata, but let's pick Git, it's the most popular one. So in the Git logs, you can have the history of who changed what and when. And with that, you can look at the code base in ways that you usually wouldn't think about, and so that's where it came with the like behavioral analysis in the sense of how did developers interacted with the code in the past, and so you can infer a lot of things like do you have coupling between things, but they're not you cannot see them in the code, but whenever someone changes this code, they also change this code, and so they are coupled in the changes over time. So a bunch of things, but in particular, the hotspot analysis I found interesting because it's a way to prioritize where to start. So you have so much technical depth in this all code base. If you take the usual take that like static analysis linters, they will tell you you have like thousands of critical issues that you need to fix, and that would take so much time. So people never really know where to start, and it's a hard sell for like non-technical stakeholders. The idea of hotspot analysis is that you take these, like where are the issues, but you also combine that with what's the churn of the code, like how frequently is the code changed. And the hotspots are the code that are complex, so that they have problems, but they also change very often. And in general, that not in general, all of the time, it depends not on the size of the code base, but on the size of the team, because it will only be hot if people are actively working on it. So that's a way for you to really focus on, okay, we're gonna tackle tech debt, but we're gonna start with these two files because among the hundreds of thousands of files that we have, these two we change every week. And it's been the case for the past 5 years. So if we do improve these two, we will have a much better return on investment. And so that's return on investment, and that kind of language is something you can come up and basically you can come up with a concrete plan for non-technical stakeholders, which will be a much easier sell if you can like have data and graphs and stuff and a plan to explain, okay, we're going to do a strategic move while we ship features and fix bugs, and then we're going to take that time to also clean up the code base, but not just clean up the code base. Like we're going to target these files, these hotspots, because we know that this is where we work the most, and you have supporting data for that.
Oh, that's very interesting because, yeah, the problem of figuring out where to start or making the most impact with the limited resources you have is very important. And especially maybe in legacy code bases where you have a lot of code, but maybe some code is just dead code, no one is using it. So having the strategy seems very interesting. And another topic that I wanted to discuss is something that you have already mentioned, that is approval testing, an idea that I found
Mm.
fascinating and very useful when dealing with code bases without tests. So I wanted to hear your opinion about your approval testing and when they are best used, in which scenarios you would suggest using them.
Yeah. So approval testing, the idea, it's what people will naturally do when they want to write tests on existing code. What they will do is they will run the code and capture whatever it does and say, okay, that's my test. So it's a test after technique, and the idea is that it's you want to execute the code to run it under certain conditions and capture whatever it does, which is easier said than done. Most of the time, the like capturing the interesting side effects and running the code in the test is the hard part, but that's where refactoring and Martin Fuller's and Michael Feeder's books are handy. It's like, okay, you can get into a test. Now that you have this into a test, approval testing, they will just give you more like it's a known problem, so they have been solved in different languages. You have libraries that will give you helpers to capture the output in a format that makes sense, and then when you run the test again, it will compare the new output with the old output and ask you for approval because it won't fail. It will ask you, okay, is this change expected? And in general, that's where most people get it wrong. They don't really pay attention to the snapshot they are capturing, and so they cannot really tell if the updated snapshot is correct or not. I've seen that a lot, for example, on front-end development, because Jest a couple years ago popularized what they call snapshot testing, which is the same idea. You run your code, you capture whatever is emitted to the browser, and then you run it again and you compare. It is very helpful because now you can start refactoring, and you know that if you introduce a regression, you will have some test telling you, hey, something changed. uh, Usually, we used to recommend to get rid of these tests once you have refactored the code and you have written more precise unit tests on it. Because also at the beginning, you don't really know what the code is doing. So you capture whatever it does. And then as you refactor, you have a better understanding of what it does. And now you can express it in more meaningful tests. Um, but, however, I just need to mention that Emily Pash has done some work around it, and she showed that you could use approval testing and keep the test and even do TDD with them, provided that you have a good snapshot, like the snapshot, whatever you capture, is readable by a human and you understand and it makes sense. And you could imagine producing a new snapshot manually because it makes more sense. The output, it's easier to grok, and then you use that to test like coarse grain what the system is doing. It's interesting. I haven't used that myself. Usually, approval testing is something I use to, yeah, have a safety net. Then I refactor, then I get rid of them. But that's the idea.
Nice, interesting. And I would like now to share something that for me was a little bit surprising when I started entering this community, when I read about your blog and also MendorCon, is that when I approached this community, in my mind, when I was thinking about legacy code, I was thinking about only about code written in legacy languages. So stuff
Mhm.
like stuff written in RPG is legacy code because it's written in RPG. And the associated practices maybe where tests are not that popular and so on. Well, for me, it's been fascinating to see that legacy code is much more and applies also to code written in modern languages. So, am I getting it right? Is that also your understanding of legacy code is broader than that, and doesn't matter the language in which the code is written, the code can still be legacy.
It is also my experience, and that's where I realized that the more you dug into it, the more you realize, oh crap, there are so many things I don't know. Personally, I have a higher expertise in web development, so like front end and back end, but on the web. Mobile development or embedded development, I don't do. I haven't done COBOL myself. So but we have enough history to have legacy code bases on the web. And so, yeah, PHP, Python, Ruby, JavaScript are the usual culprits I'm working with. Um, However, what I like with the community, with Legacy Code Rocks community, so the biggest community for like people who are interested in legacy code, uh, you have people who have different expertise areas and profiles, and so that will be complementary. For example, some people are probably more familiar with these older languages. I won't be, so I would not give advice for specialized for RPG, for instance. I don't know that, but I know some people are more into these. So I will typically redirect to these people. Some advice. Also because a lot of the legacy code aspect is the legacy culture, and this is generally the same. So some advice they apply regardless of the specific language and technology. But of course, you do have specific, like a different language will have a different approach and philosophy and a different tooling. And so for that, I would still recommend to go towards people who are expert in these specific tech, unless what you need is more of like training and getting exposed to the best practices, how to approach, what's the mindset, how to approach legacy code. So like having feedback, streamlining, how do I make a change, go to production. That is valid even if you're talking with RPG, but your reality may make it easier or harder depending on the tooling.
Okay, so it's a very broad word, and there are maybe special characteristic when working with some languages, but there is also a lot of techniques that we can learn from one from each other, and maybe take some idea, use to refactor, I don't know, JavaScript code, and maybe some of them could be applied also to dealing with COBOL or.
It's a it's a good example because so refactoring, Martin Fuller's second edition of refactoring book is using JavaScript because it's a very, very popular language. So it will it will touch a broader audience. However, when you take all of the moves, I am like, okay, some of them are valid, but they are not. I have almost never seen such code in JavaScript because JavaScript developers they tend to code differently. So some of the smells I do see very often, some of them not that often. And so, and I'm sure if you go to well, of course, Java was different, but if you go to COBOL or another language, you will have, because the language is different and the community has different practices, so you will have different recipes and smells.
Mm, okay, we have discussed a few techniques, and maybe until now we have mostly in mind, developers and how they deal with code. But
Mm,
something that you briefly mentioned near the start of our interview was also the culture. And I was
mm.
interested in knowing if beyond the technical challenges, there are some maybe cultural or organizational problems that makes working with legacy code more difficult. I know that is a broad and maybe vaguely defined topic, but I don't know if you can tell us anything on this.
Um, yes, one the main book that I have in mind about this because it resonated with me is Refactoring at Scale by Maud Lemaire. So she was working at Slack, and her mandate was non, well, it was to maintain systems, but it is a challenging environment because you need to maintain a system that is growing fast, like startup kind of environment, but used worldwide by a lot of people, a lot of money involved, etc. So there are a lot of, like, how do you do that? How do you change the wheel of the car while it's like racing on the road and you cannot stop and everything? And so she shared examples like that of how she did it. And a lot of it was, for example, exhaustive communication. You need to communicate exhaustively with everyone involved, but also you need to have ways to carry on this big modernization project that will span over a couple of months without breaking anything on prod. So exhaustive monitoring also. But how do you define like a leader and you get everyone to move on because uh, the code base is large, or many teams working on it. And if you want to upgrade something, you need to modernize it across different teams. How do you organize all of that? And so, yeah, she shares a lot of personal experience, how she did it. Sometimes also she failed, so she learned from things that could have been better. And she gave a lot of advice. I know on my blog, I have done a high level summary of cool things that I found in the book. But if people are interested in this, like how do you do that? How do you deal with the culture of the company? I would recommend her book because she really digs into. I'm working at Slack. They're not here for modernizing code in general, but they have to. So how do you get people on board effectively at scale? It was fascinating.
Interesting. And well, given our the historical period in which we are, I have to mention AI. There is not really a choice.
Yes.
And so I would like to ask you if, with respect with legacy code, do you see application of AI that are maybe underestimated or overestimated? Maybe there are things that people would expect would work, but they don't in practice, or vice versa. So, have you seen anything surprising in this?
Yeah, I will start with what does not work and what a lot of people try to make work but does not work. So the core is AI is very powerful now, so I can just write messy code or get it to write messy code and then ask it to refactor it, and that works. It doesn't work because if you just ask AI to generate code and in particular to refactor code, it will have mistakes. And not like occasionally have mistakes, it will have a mistake. You're almost guaranteed it will have at least one mistake, but it hallucinates a little bit too much, and it will miss things. And the problem is that if you do not have feedbacks about did something break and you don't master the whole thing, which is the point, usually you don't understand everything and you don't understand the new thing, it will look legit, and then you will miss a couple of potentially big issues, and then they compound. So, like, don't use AI to just refactor code. That does not work. However, there are two things that do work. Well, at least AI can help. First is to give you, like, help you understand what the code is doing faster. And when I say the code, I mean the code base. Uh, it definitely reads code much faster than you can. Uh, it's not enough because in my experience, the interaction you have with the code, for example, when you refactor it or when you read it, when you draw, I draw a lot of, like, maps of, okay, this is connected to that, etc., like small dependency diagrams manually. That is helpful for you to build the mental model in your brain that you need to work with the code, even to guide the AI. But AI can help you with, oh, I can explain this part, or, oh, have you seen that these things can be interesting? It looks like the whole thing is doing that. It's not enough to tell you the whole story, but it's a good way to speed up the understanding of a code base, to lean on your AI companion to help you understand what things are doing. And the second thing I have found interesting usage of is to use AI to help you generate the missing tests. So again, I've experienced with it. It won't get everything, but it can quickly help you kickstart, especially that people sometimes are like paralyzed, frozen in front of the code, like don't know where to start. And having AI like generate the first few tests can help you like get move on and unblock you. So AI can assist you in writing the missing tests and understand code. Now, I'm not aware of anything working yet, but I would assume that with MCP and what we're working on these days, you could have a combination of generative AI and automated refactorings, because there are some editors that are really good at automated refactorings. It depends on your language, but statically typed language, for example, there are good automated refactorings. And the idea will be that generative AI could lean on the safe automated refactorings to perform the transformations. And so you have like kind of a best of of both worlds. Um, but I'm not sure where we are at this point. I think people are working on it these days.
Well, a lot of things to unpack, but um,
Mhm.
I was very happy to hear what you said because it's aligned with the kind of things we are experimenting and using AI to give a first understanding of a large code base together with other techniques, and also for generated unit tests, and that we are in a very early stage. So it's interesting.
Mm.
And what you were saying about uh, having AI collaborate with tools that know how to perform refactoring correctly, I think that's also very interesting. And sometimes it's a little bit of a problem that these capabilities that are integrated in the IDEs are not so easily available from outside. So sometimes you need to maybe rebuild half of the compiler just to expose this capability as a library. Because, yeah, maybe say I want to rename this method in Java, but because of overload, maybe you need to figure out,
Mm.
which reference is a reference to the version of the method I want to maybe rename or move or change, and so it's kind of tricky.
Mm.
Uh, good, good. And well, about tools that make refactoring much easier, uh, can you tell us about? I hope I'm pronouncing it correctly. Abracadabra.
Ah, yes, it's so it's a side project of mine. It started for two reasons actually. So when I moved to Canada, I also was moving from when I was consultant, I was using IntelliJ a lot, uh, and it has the best support for automated refactorings that I'm aware of. And then I move and I join a company as an employee, and my coworkers they were all using VS Code. So I was like, okay, I'm gonna use VS Code too because I want to use similar tools and understand what we're doing. But VS Code had very few refactorings automated for JavaScript and TypeScript. So I was frustrated, and the first reason of building a Abracadabra was, okay, I want to bring some automated refactorings in VS Code. So Abracadabra is a VS Code extension that brings automated refactorings for JavaScript and TypeScript. That was the first reason. The second reason is it was a cool project because I wanted to dig into how do you transform code automatically. So AST, manipulating AST, parsing code, stuff like that. It's you can do automated refactorings, but any code transformation, like large scale modernization, for example, will need these concepts, linting, automating, linting rules, formatting, stuff like that. So that was interesting. And it was also a good excuse for me to, I was pairing with a friend of mine who is in, he went to Germany. So we were both in France very close friends. And I moved to Canada, I moved to Germany, so it was an excuse to have like a project to work on together and keep in touch. So we've been doing that for a while. It's still active and maintained. I do fix bugs. There are many things that it's not using AI today. I haven't changed it to use AI or anything. So it's just a regular old AST transformation to automate refactorings. But I do use it every day. For example, I do have a very nice user experience for extracting a variable, inlining a variable. I do have the shortcuts just like I had in IntelliJ. It's super smooth, and a couple more like this that I use every day.
Nice. So uh, uh, let's suggest people are missing the capabilities of IDEA to look into it. And I think it's also approaching that 1,000 GitHub stars. So maybe, add one more so we get closer to the.
It is, and I am accepting contributions. I usually have I made it contributor friendly, so it is fully tested. So if you want to, well, maybe not implement a whole new feature, let's discuss before. But if you want to fix a bug or just report a bug or do something, like feel free to. It's very easy to do so.
Okay, we have asked you a lot of questions, but now we are approaching the end. So I have a couple more questions, and one is a
Mhm.
little bit different. And in your experience as being very involved in the community in France, in general in Europe, and now in Canada, in general in North America, I was curious if you see any kind of difference between these communities in Europe and in North America.
Yes, there are differences. Because so I've moved to Canada in 2018 and I'm Canadian now, but I'm also European because I've grown up in France. And I would say the one thing I miss is in Europe, you have a lot of countries that are nearby. So you have a lot of communities because each country, they do have their communities and people are really active. So there is a lot of brainstorming, ideas, etc. It's flourishing, and you can go to a conference or many conference. It's like a few hours of driving, or you take a train. It's connected, or even you take a flight and it's like 1 hour away. Here in North America, in general, things are far away from each other, so you feel it in there are less activity. We do like when I arrived, there was no crafters community, so I created the Montreal one. Now there is one in Quebec that spawned, and some people are talking about spawning another one nearby. But so things are growing, but they are growing more slowly than they do in Europe in terms of community. At least where am I? Like in Montreal, the closest big city we have where things happen will be either Toronto or New York, but just them are not nearby. And then otherwise, you will need to go to the other side of the US. In California, for example, you have a lot of activities, but it's very far. It will be as close to me to go to France, for instance, than to go to
Ah,
California. So I would say that's the main difference. Proximity in Europe helps having a lot of events and ideas.
good. Thank you for this perspective. And my final question is there anything that I didn't ask and I should, or anything that you want to add?
That's a good question. No, there is only one thing I briefly mentioned, but I would say it again, because that helped me the most. We're talking about communities, and legacy code is can be a very difficult topic to work with, painful also for some people. Um, I would recommend anyone interested to look up for the Legacy Code Rocks. So they have a podcast, but they mostly have a community there. I am around also. There is a Slack where a lot of people are here a lot of people ready to help, answer questions, and welcoming. We mentioned before there are different areas of expertise. Like people are more into some languages, and so I feel we need more of that also, more people coming from different backgrounds to cover a broader spectrum. And there is a virtual meetup happening every week. So I would encourage people to just come around, see if like they want to fit in the community. But it was really good for me. And so MendorCon that we are organizing every year is like started from that. It's a community based non-profit conference remote on how to exchange tips, tricks, and knowledge, and also just connect and chat about how do you deal with legacy code. So I like it very much.
Good. I think it was solid advice, perfect way to end our interview. And so, thank you a lot, Nicolas, for everything you do for the community and for sharing your expertise with us.
Thank you for having me. And yeah, if you want to reach out to me, I am on Blue Sky. Also, most LinkedIn is probably the easiest, I would say, these days. So you tap Nicolas Carlo and you will find me. And yeah, don't hesitate to ask me questions. I'm reachable.
Perfect. We will do that. So, thank you.